Everyone, welcome to the webinar. This is Sydney speaking, and today's webinar will be talking about, we'll actually be taking an in-depth look at how AHRM, automatic hole recognition and machining, works. In the past couple of weeks, we gave an overview of how everything works, how to use it, but today we're actually going to go a lot deeper. We'll get give it in depth as much as we possibly can in this amount of time that we have. So let's actually get started with the webinar itself. And as usual, the webinar is being recorded, so you'll be able to see this also at a later date. And okay, so let's get started. What exactly are we doing? What exactly is the whole process when we're actually using automatic hole recognition and machining? And from this point on, I'll actually call it AHRM. What is the exact process that's actually going through? Well, what we're starting to do in the very beginning is we're actually, as a brief overview, we're starting with the solid model. We actually have a solid model on our screen as when we start working. And what we're doing is when we actually start working with AHRM, we are recognizing, we're going through the process of hole recognition. And at that point, we are recognizing all the hole features, their shapes, their sizes, and we'll see this very clearly in a few moments. After we do that, we actually break it down. And this actually tells it, okay, we break it down into different machinable features. And again, in a moment, we'll see exactly what we mean by machinable features. But these are features that, that we can easily recognize and decide how to machine it at a later point. Then, after that point, the AHRM takes it into what we call, distributes it into different feature sets. What exactly is a feature set? Well, when you're machining a part, say you have a part on a 3-axis machine, you can only do certain sets at a time. Only whatever that particular home position, that Mac position, can deal with. So in other words, that is a feature set. Whatever that position can work on, that is one feature set. If you have more than one position, if you have more than one Mac positions, then you'll get more feature sets. Now, each set of features is broken up also into their Mac positions as well. After that point, what it does, it takes each feature set and then builds the actual, decides what technology based on the machinable features, what technologies are needed to machine the holes themselves, and then breaks it up into different operations. And if there's more than one feature set, it'll go back to the feature sets at this point, and then take the next feature set and do the same process until we do all the feature sets itself. Now, what we're actually doing, as I said in the very beginning, what we call recognizing our holes and shapes. So actually, let's go into our part. I'm going to show you my other screen. And let's actually start off with this particular part. Now, there's two basic rules we must follow before we actually start going into AHRM. First rule is we have to have our coordinate system set up. Okay? In this particular case, we're talking about a 3-axis machine. So we have to have a Mac position set up for each holding that we want to have on the part itself. Also, one other thing that we must have, second rule, is we must have our target defined. Okay, so as far as our coordinate system manager, let's go into it in itself. I'll open it up. And right now, we have our very first position as shown over here. But that's good for machining this top view over here. Okay, but if we take a look at this part, I have to machine this side. I have holes to do over there, as well as holes on this side, as well as holes on this side. In other words, I need 3 more Mac positions in order to machine this entire part. In other words, in order for AHRM to recognize all of the sides and create the operations for all of the sides. So we need a total of 4. So I'm going to actually do that right now. So the first thing I'll do is I'll add my next Mac position. Okay, we'll do Mac number 2. And we will put it, say, on this side over here. And then we have our second Mac position over there. We'll accept that. Okay, I'm going to do the same thing for the next size as well. So I'll do add. And I'll do Mac coordinate system 3. Let's do it now for this side over here. And we'll do one more side. We'll add one more for this side over here. Okay, so if we take a look at the part now, we have 4 different Mac positions. We have the very first one as shown over here, second, third, and fourth. So now we have all the features can be covered, all the different holes can be covered in each one of these Mac positions. Okay, as far as I said, my target, if I were to open up the actual target itself, you can see that my solid one over here has been chosen. I'll do it again to show you exactly what was done. We have our target. If I do show, you can see that's our target. This way it also knows automatically from the target where the holes are, what holes has to be worked on. Okay, so again, we have our coordinate system manager and we have our target set. Okay, now we're ready to actually start with the AHRM. To start, we're going to go to operations. And we have the option as shown over here, hole recognition and technology. Now, since I've already done this part before, I already have a database that's part of this part, and that's called Part Hole Recognition Database. So I'll just click on it and use that technology database, and we'll explain that in a moment. Now, what we see here is as follows. What we've done here, and I'll just show it to you one more time so you can see it very clearly, is what we do is we recognize the entire part. It actually scans the entire part and picks up all the different hole features that are over here. You can see it's broken it up into shapes and groups. And now, what exactly is a shape? And what exactly is a group? Okay. We'll cover that in a moment. But note, 2 other things also open up. The moment I start, we have our AHRM manager. This is actually how we go through the steps that we need to do in order to create the operations. Besides this, we also have, and I'll drag it down for a moment, the hole recognition toolbar on top. I'll put it back on top over here. And this actually is where you can actually see the technology database that's being used. We'll take a better look at it in a few moments. We also have what we call pictures. Show picture. It actually shows the pictures of the holes, and you'll see that again in a moment. Actually, if I click on it right now, you'll see it shows us a particular picture as well as an option next to it that says show data. Now click on that as well. Now let's see exactly what's going on. First, in our hole features, you see it recognizes, it picked out all the holes on all the sides, and then it broke it into shapes. Now, in this particular case, it's showing us this shape over here, but then the shape is not enough, because you can have a shape of a cylinder hole, and we'll get into different types of segments that we have, different types of holes in a few moments, but you may have holes with different measurements. For example, we have group 1. Okay? You have these holes over here. You'll note when I click on group 1, as shown over here, we see again the same picture we had before, but in our data field, you can see that what it actually is. It's showing us that it's a cylinder. It's showing us the diameter. It shows us the height. It recognizes that it's a thread. Okay, that it's a tapped hole. And in the hole parameters, it actually shows us also what's the depth of that particular hole. With group 2, if there are any changes, it will also show us what the size of that particular hole is. Now, in shape 2, it'll show you what's involved in this particular hole. This particular hole has only one group because it's only one particular hole for this particular in this particular case. Looking at the part itself, you can see it picked out this hole over there, which is basically made up of 2 different shapes, a torus and a cylinder, showing us exactly what the dimensions are, the heights are. All of this information is always available, but it's broken up into those particular shapes, okay? And groups as well. Now, take a look at the third shape, for example. We can see that this particular shape is a drilled hole. If I show it over here, you can see it consists of a cylinder. You can see, the moment I click on cylinder, that the actual cylinder is showing over here. And besides that, it picks up that there's a cone shape at the bottom. If I go on to the next group, you can see that this particular case, it's showing us a picture of a chamfered hole with its measurements and the cylinder as well. And you can see always the picture over here. If I go to the part itself, okay, you can see that when I click on the chamfer, it shows the chamfer, and when I click on the cylinder, it actually also shows the cylinder. You can see exactly what's going on at every stage. Okay, my fifth shape over here in this particular case, you can see that in this case, we have also only one group, and this particular shape, if we take a look at the top over here, consists of this counterbore hole over here. Now you can see this shape as well. You can see that on top that has a chamfer. It recognizes there's a chamfer on top, and it gives you all the measurements of that chamfer. It recognizes that there's a cylinder over here. Okay? As you can see that this is a cylinder. You can see that there's another cylinder, which is the actual smaller hole over here. And at the very bottom, the cone shape. And each one of these, you can always see what the dimensions are of each one of those as well. Okay. So this is actually the stage of where it just recognizes the holes into different shapes and into different groups. Okay. So let's close this window now. And let's go now to the next step. What's the next step? Bringing it into what we call M features. What exactly are the M features? This is what we call machinable features, and it breaks this up into the actual segment, different segments of the part of the holes themselves. Okay? Now, let's go back for a moment to my other screen. And what it's actually doing at this point is breaking it up into different recognizable segments. For example, it shows here, these are different segments that we actually recognize. We recognize a drill machinable feature segment, as shown over here, according to the shape. A flat cylinder being such as a counterboard, the very top of the counterboard itself, the floor of it is actually flat. So that's what we call a flat cylinder. You also recognize, we can break it up into a chamfer. Also, there are cases where we have a flat chamfer, where we have a chamfer with there's a flat floor at the very bottom of it. It also recognizes thread machinable feature segments. In other words, it'll break it up into different thread segments. Okay? All of these are recognized. Let's go back to the actual part itself and take a closer look at these as well. Okay. If we take a look at the segments as shown over here, you'll note, first of all, these are all holes on the part. You can see that as well over here. You can see that pretty clearly, in fact. Now, if we go into our first shape, again, we have our shape. This is now broken up into different segments as shown over here at the bottom. It's broken up into a drill segment and a thread segment. Okay? Now, again, we talked about shape, but each one of these has a different group of different sizes. Okay? For example, if I were to open up my picture and my data as well, you can see the following. This group, okay, has a drill of this size over here with this information, and it has this particular thread size as well. And you can see that all in the picture as well. And that's all this group is made up of. Okay? Actually, all of these groups are made up of the same shapes. Okay? That's why it's put into one shape. Okay? Second group, you can see that over here. Third group, same thing over there. The fourth group, that particular case, it's over here. It may not be in the same feature, but it's the same shape. Therefore, it's in the same group. Okay? But it's a different size. We have, again, the drill and the thread. Okay? Shape number 2, you can see, again, it's broken up into different machinable segments. It has to use a drill, and it's broken up into a second segment of what we call a flat cylinder. That's what we have on top. Okay? Now, the same thing with shape 3. You can see in this particular case, it's broken up into a drill and a chamfer. Shape 4, drill, chamfer, and thread. And again, with its particular group as well. And the same thing with 5, where we have our counterbore hole as shown over here. You can see our drill hole over here. You can see the entire shape of the drill as shown over here. The flat cylinder, the counterbore with the flat at the bottom, and the chamfer, the small chamfer that it has on the very top. Now, why do we have to break it up into different segments? Well, to understand that, what we'll do right now is I'm going to open up my technology database. Okay? If I were to open up my technology database, let's close this window here as well. You'll see the following. You'll see that each segment, each machinable segment that was broken up has its own set of different operations. Okay, which we'll get into in a few moments. So we can see whatever was set up as a drill we'll use this set of operations over here. And like I said, we'll get into that as well. If something was broken up into a flat cylinder, well, we have a set of operations for that as well. For a chamfer, you can see inside technology database, we have a set for the chamfer as well. In other words, for all the shapes that are recognized, we have a set of different, excuse me, a set of different operations. This is all inside our technology database. So in other words, once we break this up into different recognizable feature segments, we can then know what to apply to what segment. Okay. Now that I've done that, we're going to get back to our technology feature in a moment. But let's go now to the next step. The next step is feature sets. Now, the feature sets, remember I created 4 different MAC positions? Well, if we take a look over here, you'll see now that we have 4 different feature sets. Our first one, our second one, our third one, and our fourth one. Each one of these is represented for a different MAC position, as shown over here. Now, you'll note that also one of them is highlighted, or I should say is in bold. That is the one that's actually currently active. That's the current feature set that I am working on now. Okay? Now, when I go to the next step, where it actually starts deciding what technology to use, it's going to do that on the current feature set. So when I click on it, you'll see that I actually start creating different technologies, groups of what we call technology 1 and technology 2. Now, for example, technology 1, for group number 1, okay, is using an option called peg drilling and tapping. Now, what made it decide, why did it use that? Because this particular group saw beforehand that it was created, that it had a drill in it. That's the segment it recognized, and it also recognized tapping. So therefore, it is using those 2 technology options. Okay? Now, why is it using peg drilling? Why not regular drilling? What made it decide to use that particular type of technology? To understand that, let's go back to our database and we'll start analyzing it a little better. Okay? Okay. Like I said, we have our drilling option. It recognizes the drilling segment. When it recognizes the drilling segment, it starts with our first option over here. Now, it starts doing the drilling option. You'll note we have drilling, peg drilling, deep drilling, 2-step drilling, different types of technology. Now, in order for it to do the first option of just plain old drilling, in other words, not peg drilling, but regular drilling, okay, it has to meet these conditions over here. If it meets these conditions, in a moment I'll get into what the conditions actually are. I'll explain the conditions in a moment. If it meets this condition, then it'll do whatever is inside the drilling technology database. If I right-click and edit, you can see that it'll do a pre-drilling spot and a regular drill operation. Okay? So what are the conditions that have to be met? Well, let's go down the line. It's showing the following. If my HR segment diameter, in other words, the diameter of that particular, of that hole, okay, is less than or equal to the maximum tool diameter, The maximum tool diameter is whatever is in these variables over here. Okay? The expression for this particular variable, maximum tool diameter, well, let's see. We have our maximum tool diameter is 25. So, let me just zoom in on these holes over here, which is what I'm doing right now. And let's take a quick, close look at these actual holes itself. The diameter that I have for this particular hole is just over 4 millimeters, 4.03 millimeters in diameter. Okay? Let's note one more part of this. We have the diameter and we have the bottom diameter. The actual distance, in other words, the depth is 12 millimeters. Okay, keep that in mind. 4 millimeters in diameter, 12 millimeters in depth. So let's go back to over here. The HR segment diameter, which is 4 millimeters, if it's less than or equal to the maximum tool diameter, which is maximum tool diameter 25. In this particular case, so far we're okay. So far it meets this criteria. It meets the criteria of being within this framework. But in addition, I've added another condition over here. What's my next condition? That the HR segment diameter is less than or equal to a maximum single drill diameter. So what's my maximum single drill diameter? 10 millimeters. Okay? So we have 4 millimeters hole. It's less than this value. So now it's so far, we're okay. But now we go to our next condition that I've placed over here. The next condition says the following. If my height to diameter ratio, okay, is less than or equal to the maximum drill height ratio, well, let's see what's the height to drill ratio. My height, we said, is 12 millimeters, and my diameter is 4 millimeters. So let's go to this variable over here, height to diameter ratio. Height to diameter ratio, we can see that that's right over here, height to diameter ratio, and we said the following. If I take my height segment, my segment height, which is 12 millimeters, and divide that by my HR segment diameter, 4, okay? 12 divided by 4 gives us a value of 3. If that is less than or equal to the maximum drill height ratio, let's see if that's the case in this particular case, maximum drill height ratio is 2. In this particular case, it does not meet this last part of the condition, so therefore it will not do the regular drilling. What does it do in this case? It goes to my next step, my peck drilling. And then it looks at these conditions over here. And if it meets the requirements of these conditions, then it'll do whatever inside my peck drilling. Let's open it up for a moment. We have, again, spot drill and my peck drill operation. So let's see if it meets the requirements over here. In this particular case, we have, just like before, HR segment diameter less than or equal to maximum tool diameter. This is 4 millimeters, and it's less than 10 millimeters. So far, we're okay over here. Next, HR segment diameter, again, 4 millimeters, is less than or equal to maximum single drill diameter. That's the 10 millimeters. So far, we're okay with that. Now, in this particular case, it's saying the height to diameter ratio is more than the maximum drill height ratio. Okay, so the height to diameter ratio in this particular case we said was 3 millimeters. It's more than the maximum height ratio, more than 2 millimeters. And the last condition is that the height to diameter ratio, in other words, the value of 3 is less than or equal to the maximum peck drill height ratio. Let's look for that over here as well. Set at 6. So since it meets this condition as well, because 3 is less than 6, then it will do the peck drilling. So it met all of these conditions, therefore it will automatically do this and not continue down to the next step. Okay? That's why in this particular case, it is choosing the PEC drilling. Okay? Now, as far as tapping goes, we have here, it'll do its tapping then. Whatever inside here, meeting these requirements over here, and in this particular case, it meets that. The HR segment diameter is less than the maximum tool thread diameter. Maximum tool thread diameter is, excuse me, maximum tool thread diameter is 16. It's less than that, no problem. It'll do whatever inside this operation over here. Okay, so therefore, that's how it decides what, by choosing by breaking it down into its different segments, that's how it decides what to use over here as well. Okay? Now this is done for every single one of these. You can see in this particular case, in this group, it's using pre-spot drill over here, PEC drill operation, and then the last one, the tapping operation. Okay? You can see also the PEC drill has 2 operations, whereas the tapping has 1 operation. This is what was inside the machining process for PEC drilling, and this is what was inside the machining process for the tapping. Okay? Same thing with Tech 2. I had PEC drill, I had a flat drill, and a chamfer drilling. Flat drill, let's open up our technology database for that. We can see we have our flat cylinder. Now, I took the first option called flat drilling. Why? Because it met these conditions as shown over here. By the way, these databases, these technology databases are installed automatically as your default inside your program. So you can always take a look and you'll see that it meets these conditions. Had it not met these conditions, in other words, my hole may have been too big for whatever reason, did not met any of these conditions, then it would have gone down to my next option, which would have been a pocket milling, where instead of doing a flat drill of 180 degrees, it'll actually do a milling operation of pocketing inside that counterbore hole. Okay? By meeting these conditions as well. Okay, let's close this. And you can see again, this particular case, it has 2 groups as shown over here. You have group number 1 and group number 2 with its respective sizes. Everything's done over here. We now generate our operations. And you can see all of these operations have been generated. Okay? Now, this, however, was done for the first feature set. Now I need this for my next feature set. Well, like I said, we go back to where our feature sets are. At this point, this one is our current one. So now I have to change my feature set number 2 to being current. Simply done by right-clicking and set that as current. Now I just go through the exact same steps. Recognize the technologies needed, and then generate the operations. For my next feature set, the same thing. Feature set 3, set as current. Group 1, the recognizing of what technology needs to be used, as well as creating the operations. And, of course, we have our last one, setting that now as our current one. Again, recognizing the technology needed and building the operations. If I go out of here now, you can see that all of my operations were created. And note these, what you see over here, these are actual regular operations. If I want to go and edit an operation, no problem. Right-click, edit, and you can see it's a regular operation. You have your drills, spot drills, your levels. All of these are open. You can do everything that's needed over here. If you want to make any kind of changes, all of this can be done over here. Any changes you want, We're not locked down into it. You have to use exactly. You want to make any kind of changes for yourself? No problem. Make those changes. Everything is open for you. Okay? Also note one other aspect over here as well. If we take a look at our tool table, you can see we have all our tools were created. Now, take, for example, our spot drill. Okay? Now, we have spot drill 1 over here, and we have another spot drill over here. Okay. Why do we have different spot drills? Because it recognized that the spot drill needed in certain holes need a 6mm spot drill, whereas other ones, which were larger, needed a larger spot drill. Now, you'll note, however, that as I go down, we have a spot drill operation over here. We also have a spot drill operation over here. You'll note that each one of those are using T1. In other words, it doesn't create duplicate tools. If it needs a specific tool more than once, in other words, through the creation of the AHRM, of the hole recognition, through the creation of the operations, it needs several times, it needs a spot drill. If it sees that the one that is needed has already been created, in other words, it's already inside my toolbot, my tool table, it will not create another one. Okay? And this goes down the line for all of these tools as well. Okay. Now what I'm going to do is I'm going to actually load a different part. And this time on this part, we're going to run it from the very beginning until the end. We'll choose this particular part over here. Now this particular part is a little more complicated. You'll note, first of all, I'm using a machine that it can do all of these holes in one Mac. I will need different positions for all of these holes. For these holes here, different position for indexing these to these hole positions as well as this one on top over here, all around the part. But as far as the Mac, we only need one Mac because this can be done all in one fixture. Okay? Now, if I were to go into my coordinate system manager, you'll note I only have one Mac and only one position. True, like I said, I do need positions for all of these sides over here. Okay. But I have at this point my first Mac, and that's the only Mac I really do need. Okay. Now, again, just like before, my target has to be predefined, and in this particular case, I'll just right-click and show it to you. You can see that we have our target over here. So now I'm going to go through the steps just like I did before. Right-click on Operations, Hole Recognition Technology. Again, since I've done this before, I already have my part Hole Recognition Database. I'll click on that. Now remember, this particular part, again, only needs one Mac. Like I said, it needs more than one position. Now, I did not create the other positions, however, okay? But I did have that one Mac there. Now, again, we'll go through the process of recognizing, where it recognizes the entire shape of everything that's in here. Exactly the way you did it last time, different shapes, different groups. My M features, breaking it down, again, into different shapes and groups based on their particular shapes, based on their particular, feature segments, such as drill segments, flat cylinder segments. All of this is recognized over here, just as before. Now, note what happens when I go to my feature sets. You'll see there's only one feature set. That's it. One feature set. Because this can be all done in all one Mac. So only one feature set is needed. Okay? build my technology, and you can see that I built the technology for all of them. It recognized all of them, knows exactly what technology has to be done there, and generate the operations. Okay? So all of this was done even on a complex part such as the one we see over here, where all the different holes, different positions, okay, all of the operations were created as shown over here. Every single one of them. If I go out, you can see all of them as shown over here. Okay? Not only that, but let's take a look at our coordinate system manager. Now, like I said, this can be done all in one Mac, but it does need all the positions. Well, if it recognizes that it was all in one Mac, that can be done in one Mac, if I open up my coordinate system manager, it automatically creates the positions for the rest of the holes. So every single set of holes has its proper position on the part. The positions are automatically created when doing this. Okay? It's as simple as that. Again, the tools, the entire tool list was created over here. A total of 20 different tools. Let's see how many operations were created. If I go down to the bottom, I have my operations numbered over here as shown. You can see 170 different operations were created. All in a matter of a few moments. Less than a minute, I created 170 different operations. And this was done by just recognizing the holes, recognizing and breaking them up into different machinable segments, and then knowing what technology to apply to each segment, and then recognize them according to the size, whether to use PEC drilling, regular drilling. All of this was done automatically using the AHRM. Okay, I think I am basically done. Again, this webinar has been recorded, so will be available on our site at some point tomorrow. And just one moment. And I see that at this point there are no questions. So, like I said, the webinar will be available on our site, so you can always review it when you want. And thank you again for joining our webinar, and we'll see you next week at our next webinar. Have a great weekend.